This week, we start exploring the SQL language and learn how to use it. In this video, we will cover some history about the language, talk about the language's various parts, and enumerate some of the most prominent advantages in using SQL. As we have mentioned in previous lessons, SQL was designed and implemented at IBM Research in the early 70s. Since then, the language is not IBM's anymore. There are many implementations of various companies. Initially, the language was called SQL, standing for Structured English Query Language, and that was developed as part of the experimental relational database system R. Then SQL evolved and became SQL, which stands for Structured Query Language. Since its development, SQL has now become the standard language for commercial relational database management systems. And since 1986, it has been standardized. The first SQL standard was achieved by ISO, the International Standards Organization, and ANSI, the American National Standards Institute. Since then, there are many revised and expanded standards that have been developed. Now there are new updates of the standards every roughly 4 years. The standards from 1999 and 2003 are perhaps the most well-recognized standards. Then other standards in between and later on have updates on these standards or extensions for supporting more and more advanced features. Now, as we said, updates happen roughly every 4 years. It takes, however, some time for these updates to come both into commercial SQL database management systems, but also in textbooks. In the later SQL standards, which are also the ones that courses are primarily based on, the language is divided into the core SQL statements, also known as the core specifications, and the extensions. The core is supposed to be implemented by all relational database management systems that are SQL compliant. Now, two comments here. First, courses on databases and SQL and relevant textbooks are not designed to teach and cover SQL in its entirety. That would be a very hard task that would require more than a few terms to achieve. The goal is rather to present the language's fundamental contracts and concepts, for example, to cover most of the core statements found in most implementations. And a second comment to bear in mind as you move forwards in this course, but also after this course, is that there is a standard, of course, but there are various implementations of the language. Individual implementations might have differences. However, the differences are not so many. The common aspects of the various implementations are more than the differences. So, what database designers do, or aspired database designers do, is to master one implementation and then to adjust their knowledge to the SQL environment they end up working with if it supports a different implementation. Now, this kind of adjustments are typically very trivial. Also remember that if what you learn here or read in textbooks does not work in the database system that you use, then, and that might be because the two are based on different implementations, then what it is recommended to do in such cases is to consult always the documentation of the system that you're using to figure out the features that it supports. SQL is called by many names. It is a universal language, as it is basically used by most relational databases by now. It is a comprehensive database language, as it has statements for data definitions, queries, and updates, and as such, it is much more than just a query language. It is an interactive query language, but also a database programming language. Last, it is a descriptive or non-procedural language that is based on relational calculus that we just saw in the previous module, but it also incorporates features from relational algebra. You will find in literature that several commands in SQL are given names suggesting that they are a distinct language, but the simple truth is that these are just parts of the language. For example, we have the data definition language, or DDL, which is commands basically for defining relation schemas, deleting relations, and modifying relation schemas, for example. Then we have the data manipulation language, or DML, which contains commands for queries, for populating the database with tuples, for deleting or modifying tuples. Other parts of the language are the integrity. So in the DDL language, we have commands that allow us to specify integrity constraints, as we discussed in a previous module. Another part is the view definition. Again, this is part of the DDL language for defining views, which we will learn about later in this course. Transaction control is another part of the language that covers commands for specifying the beginning and the end of transactions. Again, we will talk about that later in this course. SQL contains statements that can be embedded with general-purpose programming languages so that you can combine the two. And by now, the embedded SQL or dynamic SQL, as you might encounter it in literature, can be used within many programming languages. And last, we have the authorization part, which is basically DDL commands for specifying access rights of relations and views. That is, which user groups can create, delete, or modify various parts of the relations and the views. But why should we use SQL and not some general-purpose programming language in order to construct a table for data, for example? Well, there are many advantages. One of the most prominent advantages is that SQL facilitates rapid software development. With the use of SQL, the holistic procedure of developing a software, its programs, the databases, etc., becomes much shorter and easier, with, of course, felt cost-saving implications for businesses and organizations. The resulting software is often of higher quality, and it contains much fewer errors compared to cases where no SQL is used. SQL enables the data independence that we talked about in previous lessons. It also enforces the standardization among competing software development tools. Lastly, it guarantees high productivity in businesses through to the superior database management features it offers. That is, in comparison to systems that only use some high-level language and not SQL for the database development. Some examples of these superior database management features are fast access to data, support of larger files, the powerful data aggregation capabilities, etc. To sum up, this week we start our journey to SQL, which was designed and implemented in the 70s. The first standard was developed and standardized in the 80s, and in particular around the 1986 year. Now, SQL is the standard language for relational database systems. It contains a rich set of commands for various operations, not just for querying databases. It thus offers a comprehensive set of commands for database programming. It is furthermore powerful, as SQL statements can be embedded in many general-purpose programming languages.